Okay, so we're going to do an example right now that shows how to use proving trig identities when there might be factoring involved. So we're going to go ahead and prove this thing up here. So sine to the fourth of x minus cosine to the fourth of x equals 1 minus 2 cosine squared of x. So now when I go to pick which side to start with, I'm going to pick the left-hand side simply because I have a sine and a cosine. So since I have two different trig functions, I have more to work with there. So I'm going to go ahead and work with that. So when I see this, I notice that this sine to the fourth of x minus cosine to the fourth of x looks a lot like a squared minus b squared. And I know from my knowledge of factoring that a squared minus b squared is just the form a plus b times a minus b. Okay, so we're going to go ahead and apply that to sine and cosine right over here. So when we factor it, a squared for us is really sine to the fourth. So if that's our a squared, it means our a is going to be sine squared of x. So let's follow it like that. So this is going to factor into sine squared of x minus cosine squared of x times sine squared of x plus cosine squared of x. And that's going to equal, supposedly, 1 minus 2 cosine squared of x. So now hopefully you are recognizing something on the board and you're thinking into what are the tools in your trig toolbox, and you are saying, hey, I think that this is our Pythagorean identity, and I know that sine squared plus cosine squared is just 1. So we're going to replace that whole thing, and we're going to rewrite it with just the 1. So I don't even have to write the 1, so all I have now is that this is sine squared of x minus cosine squared of x. And that's supposed to all equal 1 minus 2 cosine squared of x. Okay, so again, I see this a squared minus b squared pattern right here in this line. So I'm going to reapply that factoring technique, and I'm just going to do it one more time. So now my a squared term is sine squared, which means my a is just sine and my b is just cosine. So this is going to come down to being, actually no, that's not what I want to do at all. Never mind, back that step up. We don't have to factor again. Lucky you guys. So instead, I'm going to look back at this sine squared x plus cosine squared x identity and set that equal to 1, our Pythagorean identity, and say, you know what? I only want cosine squareds, and I have a sine squared in there. So I want to figure out something to replace sine squared with. So if I subtract cosine squared from both sides of this identity, I'm going to get that sine squared of x is equal to 1 minus cosine squared of x. So what I'm going to do is I'm going to take that and I'm going to replace this into my equation. So when I do that, I'm going to get 1 minus cosine squared of x minus that original cosine squared of x that was there from the previous line. And that we want to show if that is equal to 1 minus 2 cosine squared of x. So now I just want to combine my like terms on the left-hand side and see what happens. Well, if I have a negative cosine squared x here and a negative cosine squared of x here, I know that that gives me a 1 minus 2 cosine squared x. And hey, that is exactly what we wanted. We have that on the other side. So then we are all done. So that's an example of how you might use factoring to do a trig identity proof.